in the next episode of Klingberg Wing Mark II Development. I'm Raul Klingberg, your host. Today I'm behind the camera so I can talk to you about some tubing that I'm getting ready to make. What you see on the bench here is an 8-foot length of 1.5" diameter 6061 T6 aluminum tubing, and I have overwrapped it with released material, including the graphite powder and all that other good stuff. You can watch the other video on making tubing to see how that's done. I'm going to be making 2 pieces of tubing today. One goes here. This is the mock-up of the wing attachment system, and there's going to be a piece of tubing between these 2 plates that help guide the pin in and get the pin lined up with the lower fitting once you're in the upper fitting. That I'm just going to make that out of carbon fiber, and 1 layer should do the trick. It's non-structural. It's simply a guide tube, and while I'm laying up tubing, I'll just do that at the same time. 1.5" tube. The pin is 1.25" in diameter, so there's just the right amount of clearance in there to wiggle it around and drop it in that bottom hole. So that's that small piece of carbon fiber cloth you see here. The larger piece is for a section of tubing that will be 4 layers thick. This is 5.6 ounce, 5.7 ounce plain weave carbon fiber cloth, pretty much standard stuff. That's the most common size I think you'll find out there. And I'm going to make a 3-foot length of it. And that is going to go, I'm going to show you the cockpit mock-up here. This is the leading edge area of the cockpit. And that tube will go inside the D-tube here. And it'll be bonded onto the ribs and bonded to the inside of the D-tube. We're going to have one on this side, one on the other side, of course. And there's going to be a fitting that I make that will fasten them together here in the center. And what that tubing does is it provides an attachment point where when the wing panel is joined onto the cockpit, there'll be a fitting and tubing on the outboard portion of the wing, and it will just slide right into that tube, and it'll be a nice slip fit, and that will take the torsional loads. So let's see, I'll make a little noise here, move this over. So as the pilot's back here near the trailing edge, hanging off the trailing edge, pilot's creating a down load this way, and the wing is of course trimmed out, and that means that there has to be a down load up here to counteract the weight of the pilot. That is torque that's in the wing. That torque is in this direction, and that piece of tubing will help transfer those torque loads from the outer panel all the way into the cockpit area and inside this D-tube structure. So it's both an alignment pin and transfers loads, helps carry the torsional loads that are in the wing under normal flight conditions. So, before we get too far here, I'm going to show you the setup I have for manufacturing tubing. I'm going to be making quite a bit of tubing here in the next couple of weeks. So I set up a jig or a rig to do that job. What I have here on the front of my workbench is a little corner bracket steel, threaded rod, 1/4" threaded rod, and a spring here, compression spring, and a cork. And that cork is drilled out to accept a piece of brass tubing that is sized to fit the 1/4" threaded rod. That would be 9/32 or something like that. It's K&S tubing, brass, and it's a slip fit over the rod, and that makes sure that this slides easy this way and rotates easily that way so that I can roll these tubes. So this springy thing keeps the tube tight in the jig, and it gives me enough give to where I can slip it in on the other end. Now the other end I've taken apart here so I can show you how I did these. This is a little cog wheel or a ratchet wheel, and what this does, this prevents the tubing from rolling back this way. I'm going to roll the tube this way as I put the fabric on, and this little cog wheel keeps it from going backwards. I've found in the past that when you have a large piece of cloth saturated with epoxy, that you get it set up on the tube and the tube can just unroll, and then the fabric falls on the floor, and that's bad. So I set up this little cog wheel. Now I have corks set up for each size tubing that I'm going to be doing: 1.5", 1.25", 3/4", 1/2", and they all have the brass tube down the center like this, and then they have these little flanges on here, keys, and those flanges key into the cogwheel so that the cork doesn't rotate without taking the ratchet wheel with it. Now, when this goes into this rig over here, slides right on like this. I'm not going to take the time to slip that ratchet wheel on there, but it'll sit on here like this and rotate. And then there's a pin that just floats up and down here. When I started out, I had a spring on this to force it down and hold it tight. Discovered that wasn't necessary. Gravity is sufficient. So this just goes up and down as it rotates around and prevents the tubing from backing up on me. Now, if I do get in a situation where I do have to back it up and fix a buckle on the fabric or something like that, the cork provides just enough slipperiness that if I twist the tube hard enough, it'll just slide on the cork and back up that way. So that's the rig, and I'm going to run shoot some video here while I make this tubing, and you'll get to watch as we go along. We'll start it out at normal speed, and then we'll do the fast forward so you can get to see this tubing get done quickly. And then I'll slow it up again when we take the tube off of the rig. So stand by, and we're going to change clothes and scenes here, and I'll be back in a little while. Welcome back. It's been about an hour and a half, and the tubing's out of the oven. Both pieces came out fine. The single layer one is 10 thousandths of an inch wall thickness, and it weighs a mere 0.464 ounces per linear foot of tubing, which is next to nothing. It's very light. If I get this lined up here, you'll see it's very squishy this way, but it has tremendous compression strength this way, which is what we want. Remember, it's just a piece of guide tubing for the wing pins going in. So this will work out perfectly. It adds almost no weight to the aircraft. Do an important job for us. The leading edge tubing It is 5 ounces for this 3-foot length, so it came out at 1.67 ounces per foot, and that is just slightly over half the weight of what aluminum tubing would be of the same wall thickness. The wall thickness here came out at 0.039 inches, which is right on the money, because it's about 10 thousandths of an inch per layer. We have 4 layers, and the aluminum tube that it was formed on is 0.035, and the weight on that is just over 3 ounces, about 3.1 ounces per foot. So the carbon fiber tubing, the strength of an equivalent steel tube, almost close to steel in terms of strength, yet half the weight of the aluminum tube. This is extremely stiff this way. You can't deform it with your fingers, and both of these tubes are going to continue to get stiffer over the next 5 days. It takes a full 5 days to reach final cure on this particular epoxy, so it gets harder and harder as time goes along. So this tubing will work out perfectly. They came out good. Process was good except for wrapping the peel ply and the shrink wrap. The shrink wrap was a little too narrow and required a lot of work, and the peel ply was too wide and caused problems being too wide. So I got to take the peel ply down to about half that width, down around 2 inches, 2.5 inches, and I got to look and see if I can find some wider shrink wrap. But the shrink wrap overall put a very nice load on it. It really gripped down tight on it, and these tubes came out well compressed. The other thing I would change is this is the first time I've attempted to let the fabric cure a little bit first with the epoxy on it to get tacky, and then wrap it on the tube. I thought that would be easier, and it is easier to get started. It's not easier to wrap. Having it wet and fully flexible made it easier to get the bubbles out. It wasn't quite so sticky. It was easier to twist it tight to the tube. So I'd recommend not letting the epoxy tack up first. Transfer the cloth as soon as it's wetted out to the tube, and roll it onto the tube. A little bit harder to get started, but worth the trouble because the rest of the wrap is much easier. But overall, good parts. These will go into the aircraft, and I hope you stick with me. Keep watching, and little by little, this thing's going to actually start to look a little bit more like an actual glider. So see you next time. Bye for now.